And we are back. Now, let's see if we can start implementing some of the um, actual handling of this stuff. Before we do that, let's do some data receive handling. Yeah. We know that at some point the server will send us some kind of response, and what that response is kind of depends on what's in the packet. So just to make life a little bit easier, we will do a method here that takes care of that. Let's call this data received, and then expect a packet byte array. By doing this, we can do all the checks that are needed for the authentication, both in success and in failure mode. We can do the event handling of data received, and whatever tidy up stuff we potentially need to do. So let's start by declaring a packet type, set it to 0. We also know that we need a packet ID, and we need some kind of response message. So now we've declared them. Let's see if we can actually decode this. So use our packet convert method, and as we can see here, this one expects a full packet in. It then outs the packet type and packet ID, as well as returning the payload that the packet might contain. So let's pass the packet and out to packet type, as well as out to packet ID. There we go. All right. Now we can figure out what this packet actually contains. So let's throw that in a switch. Figure out if this is something that we know. If this is a auth response, then we can do something. If it's a response value, we can do something. And in all of the cases, we don't really need to look all that deeply into it. To do, check what kind of auth response we got. We'll do this later. And here, implement some handling for all other kinds of responses. There we go. At least now we have a method that we can place a call to. We still need to do some stuff in terms of starting up in the thread, connecting, and do the disconnection stuff, and socket cleanups, and all the other cool things that is involved in messing about with connections like this. Just to make sure that I'm on track, I will check my to-do list here. Need to keep everything in the right order. Here we go. This one we did. This one we did. All right. Yeah. Let's do the thread stuff. For that, we need a method. Let's call this monitor client. No, actually, let's call this monitor connection. There we go. All right. So we know that we kind of need to keep this running for however long it's needed. We also know that we need to check for incoming data as well as process the queued up packets that might be in the send queue. And we could also here put in checks to see whether we are authenticated or not, and by doing those checks, figure out whether we need to send the initial authentication request. So monitors the activities of the TCP connection and processes the send queue. There we go. Now we still need to declare the what's it called? We need to declare a variable for the socket itself. So let's get. Oh, hang on a sec. I think I missed something. Da, 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 da. Yeah, I need the. All right. All right. Set this to nothing, just to begin with. At least now we can reference it. And let's start by. We know that when we start up the connection monitor thread, we should already have a connection established to the server. If the connection attempt fails for whatever reason, we simply just don't start this. Alternatively, we can do all of the setup stuff here in this thread, which we should probably do. So here to do attempt to connect, and then yeah, before we continue, I think we will do the startup of the thread itself. We also need to update this one. Yeah, let's do the start monitor. Start monitor will take care of starting up the thread, and then in the initial part of the thread, we will then do the socket setup and attempt the connection. Oh, for that we actually might want another event. Yeah. Okay, let's start here and go if we are not connected and the client socket equals null. We know we have an empty setup, and this would then allow us to actually do the startup itself. So we have the client thread. Let's grab the client thread. It's new thread. New thread start. And point to the monitor connection method. There we go. and we'll attempt to start it, and to make sure that the thread has a chance to start start up correctly. We will do a check on is alive, and as long as it's not indicating alive, we will simply wait for 5 milliseconds. Job done. Alright, this then starts up the thread. Starts the monitoring thread, connection monitoring thread. There we go. Alright. Up here, we shall then attempt to see if we can actually connect to the remote host specified. Now, this, just like any other kind of I/O, is prone to throw some kind of exception. For example, if we attempt to connect to the wrong IP, or a firewall is blocking us, or something else, and we are unable to connect to the remote host at the specified port, then that will throw an exception. So for good measure, and to prevent us from accidentally crashing out, we will put this in a try catch. Let's see, let's get the exception from it, that way we can report it. And for this we actually need to add another event, because since we have a connected event, we probably also want to report if this connection attempt fails. So let's give that a shot. For this we need connect failed, and since we would like to report what went wrong, we will simply pass the exception. And connect failed, and a way to raise it. Exception, there we go, and invoke this with the exception. There we go. Triggers if the attempt at connecting to the remote server fails. There we go. Alright. Now, if, let's see, we'll collapse this because we don't need it right now. And receive handling we don't need right now, so let's collapse that as well, and that brings us back here. Alright, so we know that this can only happen if the client socket is null. We also know that this can only happen if we are not already online, and since these two are will become interconnected, the only instance where this monitoring thread will actually go active is if there literally is no connection and no socket defined. So let's set up a new socket, and we need the socket type to be sorry, this is the one we want, address family, which will be the IP address for IP version 4. The socket type will be a stream, and the protocol type will be a standard TCP. which is right there. There we go. And now that it's instantiated, we shall attempt to connect to the, did we rename it? I can't remember. No, it's called remote IP and remote port. There we go. This instantiates a new socket and attempts a connection. If this fails for whatever reason, we definitely need to terminate execution of this particular thread. Now, inside a thread method, if you return, it's the same thing as ending the execution of whatever loop might be inside, which will have the thread terminate. So we will end up this exception by returning. Now we created a connect failed event, so we should pass the exception to that. That way we can hook it and figure out exactly what went wrong. One more thing that we definitely need to do is some kind of cleanup operation, because even though this may fail, this line of code should always execute correctly. So if this connection attempt fails, that means client socket is no longer null, which would effectively block our code from doing another attempt without first having to effectively destroy the object and recreating it. And there's no point in doing that. So to do some cleanup, we will go down here and do another and we should call this blah 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 stop monitor, and then we'll put in a flag that indicates whether we need to raise the disconnected event. Alright, right here we are already raising an event which will contain the error if one occurs. So when we do the stop monitor here, we definitely don't want to raise the disconnected event. Disconnected event. There we go. Alright. Right here, if we ever end up in this position here, which we of course should at some point, this is the place to indicate that we are now connected to the remote server. So let's raise that event, which is right here. There we go. Are now connected, so raise the event for it. There we go. Alright. Next up, we kind of need to enter into our actual monitoring setup and then monitor the state of the socket, retrieve some data if some is available, and also to process the queue if something is stored in the queue. So let's have a look at how we can accomplish that. Now, the quick and dirty and simple way of doing it is to basically just enter into an infinite loop that we can then break out of whenever we need to. So let's just do while true. This is literally an infinite loop, but we will add in code to break out of this while. So not a big issue. This can, of course, also be done if we, say, for example, add in a variable, a flag that indicates whether we need to continue running. But we'll do it this way. All right, and my checklist. Da, 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 da. Here we go. All right, so there are several things that can happen while we are monitoring what's going on our network connection. The server itself, let's say for example that the Minecraft server decides to crash. If that happens while we are connected, the server will automatically throw the TCP connection, which effectively places the socket into either a disconnect state or some kind of error state that we can perform a check on. So we definitely need to verify that we are still connected to the remote server. And to do that, we actually do have a public property called isConnected. So to help us in the code here, as well as anyone using this class, we'll do a quick check here. Let's declare a result and indicate that we are no longer online, and return result. Now, if something happens that causes the socket to enter some kind of error state, or if it for whatever reason is disposed of before we expect it to be, we can very easily run into some kind of exception being thrown. So let's prevent that from happening. We don't really care what exception occurred. It doesn't matter, because if the socket somehow indicates anything except being connected, then we need to return false. That's the only information we really need. So let's do a check and see if our client socket, we need to pull it, which is basically let's see what's going on. We'll do that for a microsecond. Do a select read. Let's check the, let's see, gets the amount of data that has been received from the network and is available to be read. If this equals 0, basically what we're doing here is to check and see if there's some kind of data available. If it's 0, then we don't really need to worry about it. So by doing this read selection and checking whether we have basically nothing available, we accomplish checking whether the socket is still alive. If something has gone wrong with the server and it has crashed and disconnected us, then either the poll method will fail, or client socket.available will be something different. Since we need this to be a result to check whether we are connected or not, we'll invert it. As long as we are connected, we will then get a result of true. And if for whatever reason we're no longer connected, we will get a result of false. Indicates whether we are still connected or not. There we go. Alright, so first of all, let's check if we are actually connected. There we go. Now, if we are connected, then it might be beneficial for us to figure out whether we need to authenticate up against the server or not, since we want this to be as easy to use as possible. And we have already, let's see if we still have them here. We've already declared authenticated and authentication failed events to handle the actual authentication process for us. So we might as well do a quick check to figure out whether we need to authenticate or not. And for that, we need a quick flag here. Are we authenticated? Actually, do we need to authenticate? Yes, we do. All right. Now, if we need to authenticate, then we definitely need to build up a packet, add it to the send queue, or simply just do it right away. Let's see. There we go. All right. Now, we already have a method that handles adding packets to the send queue. We don't have the send queue processing just yet, but we will get to it. So, actually, let's see. Are we still connected to the server? Do we need to authenticate? All right. Yeah, we need to authenticate, and since we don't need to do that more than once, we'll clear the flag and then send an authentication request to the server. We have the sent to server, and it accepts a packet type as well as a payload. Now, in the connect method, we have to specify the IP we want to connect to, the port to use, as well as the authentication password. So this effectively lets us do a server auth packet type and pass the authentication password to it. There we go. This then generates the needed packet for it and queues it up in the send queue, which we will process in a bit. This effectively takes care of attempting to authenticate, and we can then figure out whether we need to continue doing all this stuff or whether we need to break out and disconnect and so on. All right. Let's see. Let's check here. If we are, let's see, that is the is connected. So if we are no longer connected, we need to break out. And when we exit our infinite loop through a break, we definitely need to clean up the socket as well as raise the disconnected event. Now, figuring out exactly which end disconnected is not always easy. Partly because a disconnect can sometimes occur at both ends at the same time. That's something that is apparent when you, for example, go on IRC, and sometimes you will see something like a peer connection reset between two chat servers, and when that happens, some point of the TCP connection between those two servers derped up, but neither server knows which end it happened in. It can happen if somebody cuts a cable or a hub loses power somewhere. That effectively indicates a disconnect at both ends at the exact same time. So figuring out exactly which end disconnected can be a pretty hairy process. So for our purposes, we will simply just indicate that we are now disconnected. That's something our stop monitor takes care of. Or will take care of. We shall simply just place a call to it and indicate that we want it to raise the disconnected event. We are no longer connected, so do the socket cleanup and raise the disconnected event. There we go. Alright, now that we are messing with this particular method, we might as well see if we can implement it. Alright, so first of all, we need to figure out whether our socket has been destroyed. If it hasn't, then we need to try to tell it to disconnect. Now, to do that, we first need to tell it to shut down its communication at both ends. And again, this is something that can throw an exception, so we will ask it to shut down both ends. There we go. And then we don't care whether this fails or not. And for the sake of giving the socket time to do its thing, we will sleep for 50 milliseconds. This should be more than sufficient time for it to do all of its internal shutdown stuff, and then we can attempt to do a proper disconnect. This one. Typos. So let's do a disconnect. This one allows us to determine whether we want to reuse it or not. And since we really want to shut it down completely, we do not want to reuse it. And here again, we don't care if some kind of error occurs. If one does, then we're disconnecting anyway, so who cares? Alright. Now that we are disconnected here, the last thing that we need to do is first give it again some time to recover and do its thing, and then we need to properly close it. This again is something that can cause an exception. It's not always clear why. I have seen this happen a couple of times. I honestly don't know why these occur at random, but they do. So better safe than sorry, throw it in there. Alright, now we are fairly sure that we've shut down the communication, we've disconnected, we've closed the socket. Now we can properly clean it up and kill it. So, clean up both the socket and the monitoring thread. So let's kill the socket, equals null. Now anytime you grab a thread that is currently active, and assign a null value to it, you effectively terminate that particular thread. Sometimes you may want to do an abort first, depending on exactly what the thread does. In this case, we know that a call placed to this particular method is always the very last thing that's done inside our thread, so we don't really need to worry all that much about it. And we can therefore simply just kill it. There we go. And finally, do we need to raise the disconnected event? If raise disconnected event on disconnected. Whoops. There we go. All right. Bum, 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 bum. Shuts down the TCP connection and terminates. Shuts down and terminates the TCP. No, actually, shuts down the TCP connection and terminates the socket and monitoring thread. There we go. Should the disconnected event be raised? There we go. Alright. Now, this is literally the last thing that happens in the thread, so no problem terminating it here. Up here, the other call to stop monitor is also the very last piece of code being executed in the thread, because right after that we return. In both instances, it would effectively lead to exiting the thread method, which automatically aborts it and terminates the thread. So forcibly terminating the thread here, same difference. Alright, and just to remind ourselves where this belongs. Nope, we are no longer connected, so exit the loop. There we go. Alright, now it might be beneficial if we at some point decide that we want to add in methods and events for sending and receiving packets raw in case of some kind of additional customization of the Archon. But for the moment, we don't really need to worry about that. However, if we at some point do want to implement some extra additional stuff that allows us raw handling of this, then it might be beneficial moving this to an out of method variable instead. Since we're doing a full wrapper for this, we don't really need to do that right now, so we'll just keep it as a local variable. Alright, I just needed to check quick. Alright, let's go on. Alright, so the next part we need to do deals with checking whether data might be pending for receiving. And if that isn't the case, then we should see if there's something in the send queue. So first, let's check if there is data to receive. So if not the thread, client socket, if the socket contains some data, we will select mode, which would be read, right? This effectively waits for 10 microseconds. A microsecond is something like a thousandth of a millisecond, which is a thousandth of a second, so it's a really short time. Now, if we pull the socket in read mode, and there is data waiting to be received, the poll method returns true. So if we get a true here, there is data ready to be received. And if the poll method returns false, that indicates that the current receive buffer of the socket is empty. So no data to receive, process the send queue. Alright. Let's see if we can actually go in and grab some data. Now, the wiki page that describes the Minecraft packet size grabs some information from the original Valve source definition of this, and here states the output of the command may be split over multiple packets, each containing 4096 bytes, less for the last packet, and so on and so forth. Implementation details states that maximum request length is 1460, giving a max payload length of 1446, which means the Minecraft implementation is basically smaller than the original Valve implementation. Now, for receiving data, to us it doesn't really matter whether we set a buffer size of 1400 bytes or 4 kilobytes. So let's just set a buffer size of 4 kilobytes. Then at least we can fully support Valve's implementation of the source remote console. And since Minecraft servers will send less data, it can still fit within the buffer size. So let's grab a quick buffer and set it to contain 4 kilobytes. 4 kilobytes is nothing. We also want to know how many bytes we actually received. So let's do that. And again, we end up in a situation where we could end up with an exception. We are dealing with I/O. Any kind of I/O can always cause an exception. Assuming that it won't is the wrong assumption. Any kind of I/O can always generate an exception. Since we don't want our application to crash in case something goes wrong, we will put it in a try-catch. But we don't really care about what might go wrong. Alright, received bytes equals client socket dot receive. We will then pass the buffer. Let's see if we can find the right one. This would be the right one. Receives the specified number of bytes of data from a bound socket into a receive buffer using the specified socket flag. Size the number of bytes to receive. Now, since we know from the source page that the maximum size is 4 kilobytes, we will simply specify buffer.length, and we don't really want to add any specific flags. We just want everything raw. Done. Now, if an exception occurs here, we can very quickly and easily ignore the contents of whatever might have been thrown into that buffer by simply setting our received bytes to 0. Whatever might have ended up in this buffer when the error occurred could be garbled data that's basically useless, so we don't really want to deal with it, so we will just force the received bytes to 0. However, if we did receive something, the received bytes variable will now contain the exact number of bytes that we have received. So, to make sure that we don't end up having too much data because the buffer is 4 kilobytes, we will do a local copy of the actual number of bytes that we received. So let's grab a quick new byte array here, which has the length of the number of bytes received. Then we will copy from the buffer, starting at position 0, into our local data buffer at position 0 and the total number of received bytes. Now, after this, data will only have the length of the actual number of bytes we've received. So from here, we actually have a method up here that's called data received, which handles all the stuff for us. So we will simply just pass this data to data received. There we go. Then we'll clear the array like so and kill the buffer equally. There we go. The reason I do these cleanups, strictly speaking, they might not be needed because the .NET framework internally handles destroying variables that are no longer in use, depending on scope and so on and so forth. But back in the day when programming languages and compilers and frameworks were less intelligent than they are today, we actually did have to clean up stuff ourselves. In modern day programming, if you as the developer choose to play nicely with your compiler and your language environment, by cleaning up after yourself, you effectively flag this particular variable for garbage collection. That leads to less risk of memory bloating. And that is definitely issues that we have seen time and time again. Games in particular are particularly bad at ending up in a memory bloat situation. So play nice, clean up after yourself. It does help you down the line in terms of increasing performance and increasing stability of whatever it is you're developing. Alright, data received, buffers cleared, we are done. Alright, just for the sake of, since we are here, let's go see what this packet actually contained. So, we already did some of the work. Forgot to document it. Processes the data received from the server. The packet received, bata, and we already know that if this is a malformed packet, response message will be empty, packet type will be -1, and packet ID will be -1. Now, since we don't have a packet type that is -1, this switch statement will simply be ignored um, because we are not checking for a packet type of -1. But we still need to figure out whether we are currently in an authentication process or we have gone past authentication and therefore need to handle some kind of command response from the server. Let's do a quick chat check. There we go. All right. For the authentication response, the protocol states that, let's go to the source description because it's more detailed. Let's see, auth response. Here we go. Now, the type will always be 2. And if we do a quick verification, server data auth response is 2. If the authentication was successful, the ID that we sent we will effectively get back. Now, if the authentication, on the other hand, fails, then we will get an ID of -1. So we can fairly simply and easily verify that we actually did get a correct authentication by simply comparing the packet ID with the last packet ID. Now, if this is the case, then what do you know? We are now authenticated. However, if the packet ID equals the extra variable that we put in here, which is -1, then derp, we actually ended up having an authentication failure. Now, here we can put in a choice. If for some reason the authentication failed, the server might, depending on how the server is implemented, it might allow us to do a retry, effectively sending the password again along with the authentication request. However, the server may also choose to disconnect us if the authentication failed. At the moment, we have no idea how the server at the other end acts. So for now, we will simply just leave it as is and see what the server does. Note, here we could add in a forced disconnect or a authentication retry. We'll leave that in there. This is just note to self in case we want to change the behavior of some of this at some point. Now, the other part that we could end up here having is some kind of server response. And since that needs no extra additional handling, we will simply just raise the server response event with whatever the response message was that we got from the server. We know that the convert packet method handles splitting out the contents of the data packet and even ensures that the response message is just an empty string if we didn't receive anything from the server. So we don't really need to do any further processing of this. The next thing on today's agenda is implementing the send queue processing. So just like before, when we need to process the queue, we might end up in a situation where we are attempting to check on the queue while the other thread that started this is about to add something to the queue. So we will do a quick thread lock the send queue to prevent desync. Do this by locking it, send queue. There we go. Now that it's locked to this thread, we can then do a quick check. Does the send queue counter have any entries? Do we have a message to send? If we do, then we shall grab the next block of data to send. And we'll do that in a buffer and simply just dequeue1. There we go. Once this is done, we will attempt to send this. Ugh. I'm full of typos today, sorry about that. So, grab the client socket, attempt to send the buffer, and for this we need to tell it what to send, how much data to send, and what kind of flags we want to use while sending it. Just above we declared data block, and we need the length of it, and we don't want to specify any specific flags, just send it raw. Now, if an error occurs here, it could be because the connection was broken, orphaned, or disconnected server side. If this happens, then we effectively need to disconnect and clean up the socket. This is the only instance where we have maybe 80% certainty that the TCP connection was broken closer to the server or by the server itself rather than being on our end. But it's nowhere near reliable enough. At the moment, we don't exactly have anything to indicate that we need to disconnect. So to do that, we will go up here somewhere. Let's see, receive, handling, send, handling. Nah, we will go up here. There we go. Let's grab a flag here. By flag, I mean a Boolean value, since it can only hold true and false. And call it disconnect client. Set it to false. The only instance where we will set this to true is when we either call the method to disconnect or if the error that we just ran into down here occurs. So if this error occurs, then we will set the disconnect client flag to true. And then down here, this would be the end of the while. Yes. Let's grab this and put it down here just to remember. Now, if disconnect client is true, then we break out of the loop, which will then place a call to our method to forcibly disconnect, clean up, and stop the thread from running. So, nice and easy way of breaking out of our current loop. There we go. All right. This effectively takes care of the send queue. Let's see, this one would be the lock. So what happens here is we thread lock the send queue to the current thread, which is the networking thread. Then we check whether there's something in the send queue. While this is going on, the send queue cannot be modified from the other thread, and the other thread will have to wait for this to complete. Now, luckily, if an error occurs with the socket in at the moment where we try to send data, that exception occurs pretty much instantaneously. So there will not be particularly any particular big issue in locking the send queue to the networking thread. There won't be any kind of delay. The only situation where there might be a slight delay is if the send method encounters some kind of networking error while it's actively sending out the bytes in the data block buffer. But again, this kind of network crashing is something that is almost instantaneously going on, so we won't end up with a 30-second thread locking in this situation at all. It won't ever happen. So it's not something we need to worry too much about. Alright, we now have the ability to receive data. We have the ability to process a message queue, the send queue. We also have means to detect if something goes wrong with the connection and then effectively disconnect and terminate the active connection, dropping out. We have methods and means to raise the different events. We have the actual processing of the packets coming in and out. We even added in an automated authentication request being sent to the server, but we still need to implement some of the public methods. So let's go down and check those. Alright, this would be the connect method. To do, add in code to actually start connecting. Yep, let's do that. We have a start monitor method right here. There we go. Fire up the monitoring thread which attempts the connection. There we go. And we also need to be able to disconnect. But if we want to use the disconnect client flag to control the monitoring thread, we actually need to change the declaration of it. So let's put this here for now. Go back up to the top and change the declaration to volatile. Now volatile allows us to modify the contents of the variable across both threads without causing desync. I honestly don't know the full implications of what volatile means and exactly does. Pretty sure that we can Google it, but I know that it's needed for this particular scenario. So declaration changed, and we should now be able to do something as simple as setting this to true. Sorry. Now, it would probably be beneficial to do a check to see whether we are connected or not, and then just place it here. The result of doing it this way is that we can change the flag setting across the two threads, allowing us to tell the monitoring thread to go through its disconnection process, and all without us having to wait for the entire disconnect process to finish. So it's instantly disconnect, and then all the stuff happens in the background across the other thread, do the cleanup, do the disconnection, and all that stuff. Quick and easy. Alright, one more thing that we still need to implement is to figure out whether we have actually been authenticated or not. And the reason we need to know that is to find out whether we can actually allow the user of this class to try and execute a command remotely. If we are not online, or we are not correctly authenticated, then the server might ignore any attempts at sending a command execution request. But for the sake of our sanity, we will simply prevent that from happening if we are not online or if we are not correctly authenticated. That way we at least don't have to do any kind of queue processing if we're not already connected. So, to accommodate that, we will add another flag here. Now, across threads, without sync locking, you can still check the contents of a variable without desyncing between the threads. So that's not a huge issue. For the sake of keeping our stuff in check, we will see if we are authenticated. Now, this particular flag, oh, we actually have something for authenticated. Yes, of course we do. We have an event. So, let's rename this to client authenticated. There we go. No more conflicts. Let's go grab this and go have a look at our monitor thread. Wherever it is, we can get rid of this right here. Alright, so here we will initially force the authenticated to false. We'll grab this one that indicates that we have to authenticate. Maybe we should rename that. Nah, it doesn't matter. And if we authenticate, then do that, and then we can do a check in the receive handling. Now here we already know that if the packet ID equals the last packet we used, we end up in an authenticated state. So let's change our flag here to true. And we now have a way of checking whether we can execute a command. So if we are connected and this client is authenticated, then we can place a call to send to server, allowing us to specify a packet, which would be execute command, followed by the command that we want to execute. This then converts it into a full packet and queues it up in the send queue. And that should be it. Right, we have the means to connect to a server. We have the means to authenticate. We have the means to disconnect from the server, process execution of commands, and so on and so forth. So, I guess it is about time to put this thing to a test, just to see if we have bugged up somewhere. Let's get these expanded. Server response, authentication failed, disconnected, connect failed, and connected. All right. Let's go over here quick, and then just like we did here, for now I will do a test scenario just to test that what we have just implemented actually works. So for that purpose we will add in a test archon handling section. Alright, then we need the source remote console, and we'll call this archon equals new source remote console. There we go. Then we'll do a initialize archon, because we still need to hook the events. So archon dot authenticated, archon dot authentication failed, archon dot connected. We also have a connect failed, and we have a disconnected event. There we go. And finally the server response event. Alright. Let's try and see if we can put these in a more logical order. See, the first thing that the first event that could occur is either the connect or connect failed events. After that, we can either get the authenticated or the authentication failed events, followed by potential server responses, and finally have a disconnected event. In reality, it doesn't matter which order you hook the events in, or how you choose to put these up. Personally, I like to try and organize event handlers and event hooking in a manner that seems logical according to what happens with these events. All of that is personal preference or up to the individual developer's laziness. Some don't care, some do, some have very strict rules for how things should be organized and so on. But at the end of the day, it's up to personal taste. And authentication failed, blah blah. Disconnected here and server response there. Yes. Alright, cool. Now, before I start implementing these individual events, I will remember to go down here and initialize these. So, let's put that here. There we go. And then we can go back up and handle all these things. Now, since we're doing this across threads, it might be a good idea to check whether we need to invoke it. So, if invoke required, then invoke new action. And since we don't need to pass any kind of values, we can simply just pass the method and then bug out. And here we'll put a diagnostics debug right line. Whoops. Connected to remote server. And we'll do, I don't know, like this. Same thing here, invoke required, then invoke this, and in this case we need to pass an exception. The method name followed by the actual data itself, and here again this is force of habit, doing it this slow way, sorry. Connection to remote server failed, and then error message and the exception message. There we go. Okay, and here we'll do it again. Invoke required. Invoke new action. Here we don't need to pass any data, so we'll just pass the method. There we go. Return. Do the debug. Successfully authenticated. There we go. And this would be the authentication failed. And there we go. Grab this one. And dump a message. Authentication failed. This is likely due to incorrect password. Boom. There we go. And in this case, it's the invoke. We might get something back from the server. We might also get an empty string. So overall, we'll just handle it from there. Again, invoke. And in this case, we need to pass a string. So we'll pass that. There we go. Response message. There we go. Server response received. And here we go. Message length, just for the sake of it. Response length toString, and then throw the actual message and see what happens. There we go. Message. Response. Let's go here and add the response message. There we go. Alright, and then we can do the disconnected. Invoke required. Invoke it. And again, here we don't need to pass any data, so we'll just specify the method itself. And this needs to be uppercase, of course. And then here, throw a debug message for ourselves. Whoops. Right line. Disconnected. Archon. Disconnected. Yeah, that's fine. Alright. Now at least we have some means to check what happens. Next up we need to put some controls on here to actually use it. Now, for this particular test, let's see if we can move these a little bit. some space. There we go. Since we haven't implemented any kind of password and port configuration or anything else, we will go and grab those from the server properties and just use those. Which we have right here. Let's see. Archon port is set to 26665. So we definitely need that for testing purposes. Archon port equals, and we also have to find the password, which is right here, randomly generated. So we shall use this. Archon pass equals that. Okay. Now let's see if we can put a couple of buttons on here and maybe a text box so we can type in a command and try and send it to the server. So let's see, we need a connect button. We also need a disconnect. So let's grab that. There we go. We need a text box. Put that here and call that txt command, which is fine, and then an execute button. Execute. There we go. Execute. Boom. All right. Let's grab the events from them quick. Get the connect button, the disconnect button, the execute button, and that should be it for now. Let's grab these and move them up here somewhere. Since we're just doing some testing here, I think I'll just put them in here. Quick. There we go. Test buttons. There we go. All right. So, did we have a way of figuring out whether the Minecraft server is running? We probably don't. Let's see. Minecraft server. Let's see. ID ... We don't have any way of telling whether it's running or not. So let's add that in quick. Grab this one. Private bool running equals false. There we go. Okay. So when it is running, we shall see server started. There we go. So we shall put this one to true here. And then if it's shutting down, then we'll set it to false. And we shall do that in the server stopped event as well. There we go. Now we have a flag, so we can check whether we can actually attempt an Archon connection or not. Alright, if Minecraft server running, then we shall see if we can archon.connect. We need a new IP. And for that we will just specify localhost 127.0.0.1, and the port number is whatever we put up there, and some kind of password. So let's go fetch those quick. They are here. Where did my button go? My button is lost. Oh, there we go. Alright, so port is this. There. And the password is this. So we'll put that in there. This will then attempt to connect to it. We'll disable the connect button, and this one, let's see, if Minecraft server running, and if the Archon is connected, just for the sake of giving us the option to actually do the checks, we'll have it disconnect here. There we go. And since we're disconnecting, we will disable the disconnect button. There we go. Alright. And again here, if this is running, and if the Archon thing is connected, we shall see if we can Archon execute whatever is in the command text box. Done. There we go. Alright, last thing we need to do is to grab our events here, connected. If connected occurs, then the disconnect button should become enabled. If connect failed, then we can just force a Archon disconnect here, and then set the connect to true and the disconnect to false. Just to update the UI stuff. Authenticate it. If we authenticate correctly, then we can do the command text box, enable that, and the execute button, enable that. There we go. Authentication failed, blah 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 blah, server response, and then the disconnected stuff. This would then mean we need to enable the connect button. There we go. We need to disconnect enabled false. We need to disable the command text box, and we also need to disable the execute thing. There we go. And for the sake of keeping some consistency, in the form shown event, which is right here, we will add those in as well for the Archon test. Alright. Let's see if this will actually run, or if it will crash. Alright. Last time we already we built up a all of the launcher code that is capable of starting up the server, triggering the events, and also listens for shutdown information. So let's see if we can actually start this up again. Minecraft server is, as we can see in the output below, and it now says that we are connected. We have the standard vanilla UI here for it. It says the Archon is running on this port locally, So let's see if we can actually connect to it or if our application ends up crashing. Boom! Holy smokes! Minecraft server launcher loaded, blah 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 blah. Um, null reference. Well, it seems we have a null reference exception occurring somewhere. However, interestingly enough, connected to remote server, the server's console said Archon connection from localhost, and it actually responds with a successful authentication. So that effectively means that we should now be able to type in, say, list in this box, execute it, and server response received, message length. There are 0 out of 10 players online. Holy smokes, it actually does work. Just for the sake of it, I already prepared it here, so let's join this and see what happens if we execute that command again. Right. For some reason it's highlighted down here. Let's get rid of that. Which would be this one. Actually, grab this one as well. There we go. Let's do the list again and see what happens. Oh, there are 1 out of 10 players online. Sure then. Awesome, it's actually working. So we should be able to disconnect now, which tells us that Archon disconnected, and it also tells us that the thread that was running the Archon has exited with code 0, which means successfully quit. We should now be able to reconnect, and something has gone wrong with that aspect of the class, so that's something we will have to debug. For now, let's just stop this. There we go. Server connection lost, and this one cleans up correctly. So let's see if we can figure out what goes wrong with the Archon class that prevents us from reconnecting. So, let's see. Welcome, Mycon. Well, this is basically a kind of maintenance, or it is going to be a kind of maintenance launch wrapper for Minecraft servers. I've got a modded Minecraft server running from one of my computers here for my closest friends, and I'm also running a vanilla server, and both of them are running on Windows environments. And yes, I know it's bad, but the whole purpose of creating this particular server launcher is to construct a launcher application that can handle both of my servers, including posting messages in both of the game server chats, warning players that this server is about to shut down for daily maintenance or scheduled restart. As part of the maintenance aspect of it, I want this launcher, server launcher, to be able to make a backup of the game worlds, including all player accounts, so I can have this do the daily backup for me. And along the way, maybe showcase a little bit of what kind of code it takes to build something like this. As such, there's nothing special about it, except, well, I have the full freedom to make this server launcher and monitor, maintenance bot, whatever you want to call it, do whatever I want it to. Down the line, for example, I could add in, say, a Discord bot that can be configured to join a specific Discord channel and maybe post messages there, or start acting as a chat interface between that Discord text channel and the in-game chat. That's a possibility, but have it available as a all-in-one package. Anyway, there was some kind of problem with the Archon class. For some reason, it didn't want to reconnect after having been disconnected. So let's see if we can figure out exactly what goes wrong. Get rid of this. And this we definitely need. So first time around, we know that this one will succeed, so let's just fire this up again and see what happens. For now, the launcher isn't particularly beautiful or functional. Down the line, a lot of this will change. This is strictly just the initial startup stuff for running all this. As a sort of build platform to get individual parts of this stuff working. After that, the plan is to start grabbing some of all these individual classes, rebuilding them a little bit, and then do a better interface to allow support for multiple servers and so on. That would definitely be an option too. Given that through the Archon interface I can actually send console commands to the server from my launcher application. I could even do things like if I had some kind of permission plugin running, I could update a player's permissions. Tons of different things are possible. The main focus of this project right now is to be able to start up a server, grab the console output from Java, which you can see in the output panel at the bottom of the screen at the moment. It's exactly identical or almost identical to what the Minecraft server window is currently showing. That would be the direct output from Java that I've captured in my server launcher application. The next part is the bottom half of this window. The connect, disconnect, text box, and execute. Those interface directly to the source remote console class that I've created today. Which follows the specifications of Valve's original source remote console protocol. And since Minecraft more or less one-to-one copies using it, it will work for Minecraft servers as well. Well, some command blocks might be triggerable as long as you can reference them in the console. Anything that you can do in the server console or as a server operator is something that you can do through the Archon protocol because it effectively becomes a remote copy of the actual game's console. So let's see. Oh yeah, right. I'm still getting that null reference exception. But I need to figure out where that occurs. Let's see. For now, let's go here, put a breakpoint, and then go back here and here, and just disconnect again. Alright, thread has exited. And let's see what happens here. Alright, connect. Exactly. That is definitely possible. Okay, so we have the remote blah 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 blah. Ah, yes, actually, I think I might know why. Yeah, let's step through it and check just to be sure. Is connected is false, and the socket is null. Absolutely yes. Client is alive, blah blah blah. The monitor has started, and then let's see what happens. This connected, and what happens then? Console changed. Ah, okay. And disconnected. And this, of course, occurs because I have forgotten to pre-initialize the authentication stuff and the disconnect client. So a derp on my part. Alright, cool. Since we can't stop it here just yet, we need Archon for that. We shall simply stop it here. Boom, done. Alright. See, one thing that I did forget was to clean up this one and clean up this one. These need to be reset back to false, both of them, when the disconnect occurs. So, to do that properly, we need to grab the stop monitor method. There we go. Hey baby girl. Which is right here. And here is where I forgot to super derp. Alright, let's see. Remember to reset your flags, you derp. So, client authenticated, reset that, and the disconnect client, reset that. Must be set to false, otherwise it'll force an instant disconnect. There we go. Now we should be able to connect, disconnect, connect, disconnect, connect, disconnect, connect, disconnect. Let's give it a shot and see what happens. Start the server. Well, thank you very much for the follow. And the server is up. And as we can see, the Archon is correctly listening. And let's connect here, remove the breakpoint, and boom. Let's get the there we go. Let's grab this one. As the button indicates, we are now online. Note the output window down here that currently holds all of our debug information. We'll do a quick list and execute. And it currently says nobody's online. We shall join the server. Go, we are now logged in. Nice. And nah, right now it looks very much as if it's, yeah, it's raining. Yuck. Let's do something about that. Type in weather clear, execute. And what do you know? Now we have clear weather. Yay! Very cool. Alright. Just for the sake of testing that we can actually reconnect with the Archon, I will disconnect. Thread has Archon disconnected, thread has exited. Let's try and reconnect and see what happens. Successfully authenticated. Do another list. And it says there are 1 out of 10 players online, Sheridan. Archon now works completely. And since we are now running the Archon protocol in a separate class, we have the option to reuse this code for whatever else that supports Archon. It doesn't exactly have to be for Minecraft. Valve has a couple of products that support Archon, and I know a couple of other game servers also support this protocol. So in essence, this one single class now more or less fully supports any environment that runs with this particular protocol, which is pretty cool. And just for the sake of it actually does work, successfully authenticated, let's tell the server to save and then stop it. Da -da 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 -da. There we go. Everything updated correctly. Very nice. So this means that we now have pretty much everything we need to update our server host class, which currently hosts the Java instance for the individual Minecraft server. So if we implement internal handling of Archon and then just grab a couple of extra properties to say, for example, generate randomized passwords, maybe set a port range, or a fixed port, then we could actually have the server host class handle all of the Archon stuff as well, if we just want to make it a dumb controller. So that's definitely another option that we have available to us. In any case, it's been about 2 hours since my last nature break, so I think I need to go on another nature break. Coffee has a tendency to make you need to take a break every now and then, so I shall be back in a bit.